In this review video presentation, I'm going to talk about this article, using spatial analysis and Bayesian network to model the vulnerability and make insurance pricing of catastrophic risk. Firstly, I will introduce the background of this technique. Nowadays, people pay more and more attention on the loss of lives and properties from catastrophic disasters. The catastrophic events can cause huge loss of lives and properties, and there are some examples as follows. Therefore, there is an urgent need for new technologies to forecast and prevention before the disaster, mitigation during the disaster, assessment and planning after the disaster. By far, the geographic information system as a geospatial technology has been widely applied in assessment of nature disasters because of its efficient spatial location and management of spatial database. But there are still constraints of using GIS. Many assessments of catastrophic risk are based on area aggregate method called AAM, and it is not suitable for high accuracy location of risk. Most methods are classical statistic or fuzzy comprehensive evaluation, which limited in the uncertainty of predictive indicators and their interactions. But Bayesian network can improve to apply spatial vulnerability. The spatially explicit modeling environment for our approach contains GIS, spatial analysis, and Bayesian network to conduct vulnerability assessment and insurance pricing. This model is based on the great dataset to present the predictive indicators and target variable, and extract the table of attributes. This format has advantage to collect data and integrate for further analysis, and the technicals of spatial analysis as kernel density analysis called KDA and accumulated road cost surface modeling are used to do geospatial analysis. Then after Bayesian network assessment, we can model the vulnerability and insurance pricing. To talk about Bayesian network methodology for vulnerability, firstly, we need to know the indicators involved. There are two types of indicators. The indicators related to exposure are directly related to the occurrence of natural disasters, in which most are natural and a few are artificial. The indicators related to vulnerability include environmental indicators and system-resistant indicators. Spatial analysis technique used in this approach is to pre-process and quantify the discrete or qualitative indicators for use with other quantitative indicators, and the kernel density analysis is especially useful for processing those qualitative spatial features and quantify them to be used with other quantitative indicators. KDA transforms a sample of observations recorded as point or polyline data into continuous surface, which indicates the intensity of individual observation over space. Bayesian network modeling framework is based on the belief of a hypothesis according to exposure-related or vulnerability-related indicators, and vulnerability assessment is to estimate the degree of damage of individuals exposed to nature disasters. The mathematical formulas are shown as follows. As insurance pricing, the more vulnerable is the insured individual, the higher is the premium. We use Bayesian model calculate the insurance rate and take this value into the second formula to compute the premium. All the parameters used in the function can be collected from the grid dataset and data table. The last of Bayesian methodology Uncertainty and sensitivity analysis. Uncertainty analysis is to detect the uncertainty of the indicators and decrease such uncertainties. In this approach, we use the upper and lower bounds of the 95% Bayesian confidence intervals to represent the uncertainty. And the sensitivity analysis is to determine the influence of epistemic uncertainty in terms of two kinds of uncertainty. To make sure the sensitivity of target variables, we can use the following functions. In this article, they use earthquake disaster as an illustration to present the model, and the result is impressive. Compared to the traditional method of AAM, this approach almost has improvements in all damage states, providing more precise prediction. And by using this approach, we can take advantages of spatial analysis and GIS to assess, visualize, and locate the vulnerability and insurance rate. In conclusion, with given uncertainty of natural disasters, we can propose a Bayesian network for vulnerability assessment and insurance pricing of catastrophic risk. For future improvement, we can combine domain knowledge and learning from spatial data to get the interdependence between some variables to enhance the prediction. Considering the influence of temporal factor, the temporal node can be added into the Bayesian network to improve the hazard analysis and enhance the accuracy of the forecast. And we can extend this approach to other types of catastrophic risk and set up specific models for each type of disaster. That's all. Thank you for your attention.